Hi everybody. Oops, sorry, it's a little bit loud. Just one question. The organizers asked me to do this talk normally in French, but I don't know if you're okay with English. Maybe it would be better for foreigners, and if you are okay with English, let's go in English. I'm not prepared to talk in English, but well, we'll see. And I can still use French if I'm searching for some words. So. Thank you for being here. Thank you for Droidcon for inviting me to this conference, great conference. And today I want to talk about scrolling techniques on Android. So what I do most of the time, so if you remember my talk last year, it was about deep dive into Android state restoration. What I'd like to do is to pick a subject that is, well, known as natural or common, and try to deep dive into this one. And I think scrolling is one of these subjects. So one quick introduction. My name is Cyril Mottier. So you can find me on Twitter or Google+. I love football, table football. I love running. And I'm also an Android Google developer expert. So that's what I do on my personal time. But what I do, professionally speaking, is working for a company called Captain Train. And what we do at Captain Train, we are just revolutionizing the way that you travel by train and you buy train tickets. Very simple to explain, very hard to code, and very hard to do. So basically, we're based in Paris, and we are also hiring. So if you do this, curl-i on the domain, you will see that there is a header, X recruitment, and you can go to this nice URL, and you will see that we are hiring in a various kind of positions. So engineering, of course. If you're doing that, I think you can apply to engineering. But we're also looking for support guys, marketing, product, and all of that stuff. So that's it for the introduction. Let's start with why we are here today. So I wanted to do a small joke. So Joe, Max, and Kevin are in the boat. But the thing is, I thought a lot about this joke, and where you don't develop on a boat. So I needed to change a little bit the beginning of this joke. So Joe, Max, and Kevin are designing an application. And this application is quite simple. It consists on displaying a bunch of quotes from popular movies. So for instance, here you have a quote from Cooper in Interstellar. And then there is a quote from, I don't remember which one, but we'll see later. And as you may have understood, Joe, Max, and Kevin are here faced with one problem. The thing is, there is a lot of quotes, so all of them can't, fit inside the screen. So there is several solutions here. So Optician Joe, like Emotion Joe, Optician Joe is, well, an optician. So his solution is to reduce the size of the font. Well, that's a solution. All fonts are now inside the screen, but the font size is so small that you will probably need some new glasses or maybe even some magnifying glasses. So Joe's solution is not the best. Max has another solution, and Max is a salesman. So his solution is to buy something bigger, like a tablet or probably a TV. And here again, you can read now, you can read the quotes, and you will have all quotes inside the same screen. And Kevin, if you remember Kevin, that was the guy last year who was using, putting all the config changes to prevent the system from restarting his application. Well, now Kevin is a little bit more experienced, and he came up with another solution, which is, well, scrolling. Inside of, changing the device or changing the size of the text, you scroll the text inside a bigger content window. And this actually is probably the solution that you all thought about at the beginning, because we are all Kevin in this room. The thing is, scrolling is so natural nowadays that you don't have to think about it. For you, it's not an option, it's the option. It's the only one option. And that's because scrolling is essential to all UIs, not only mobile, more over on mobile, but especially on mobile, but everywhere actually. And from my point of view, it's, well, I consider it as the most important gesture on mobile, even before tap. Because let's say, for instance, you want to open an application. What you will do first is to scroll to the correct page, or in the navigation, the application drawer, you will scroll to the correct scroll position, and then you will tap on the application icon. So scrolling is really at the root of all UIs, even on desktop. So what is scrolling? So this is the definition of scrolling. It's the general process of moving a viewport, that is the window of content you're looking at. So scrolling is not, it's not an action. It's not, you know, touching a screen and then changing the position of your finger. It's an interaction. That means that actually scrolling can be done not only by a touchscreen, but it can be done via some other gestures like a trackball, or, I don't know, a pointer like that when you are on a TV. So the interaction is very different from the action. And you will see that most of the time, people always consider scrolling to be done via a touchscreen, but that's not always the case. You can do it also programmatically. And scrolling can be divided into two parts. The first one, most of the time, is dragging. So a drag is a type of scrolling that occurs when a user drags her finger across the touchscreen. So this is basically when, let's say, I'm having I don't know, let's say, you know, this mobile phone, when I'm doing that like this, it's a drag. I'm moving the phone over the table. And if I'm throwing it at a very rapid velocity, then it will, you know, fling. So basically, it will move until a state of rest. And that's what a fling is. It's a type of scrolling that occurs when a user drags and lifts her finger quickly. It's also known as inertial scrolling. So when you throw a ball, for instance, you don't expect it to stop right in the middle of the air. You expect it to move and to bounce until a state of rest. That's what a fling is. So whenever you have scrolling, most of the time you will have to split your scrolling mechanism into two parts, the dragging part and the flinging part. And that's what, for instance, you can see, let's say, in a ListView. When you're dragging it with your finger, it follows your finger, and if you throw it away quite rapidly, it flings until it reaches a bound or it stops because of the friction. Well, theory friction. So this is the diagram when you're starting Android and you want to create something that is scrolling. This is the kind of containers that you will use. So all of those scrolling containers are actually available in the SDK or in the support library. And well, as you can see, it's a little bit complex. So let's dive into this diagram and understand what it means. So the most basic scrolling container you can find in the framework is actually View. So, oops, sorry. Sorry about the trolling. So the View container, well, it's not very visible. So the View container is the most simple container you can find. Actually, yes, View most of the time doesn't scroll, but it supports scrolling internally. What you will use most of the time is a view group like a text view, which scrolls. So for instance, if you are sending a message, you will see that if you start typing a lot of text, you will have multi-line text. And at the end, because of the height of the text view, instead of changing the height of the text view, the system will allow you to scroll the text inside the text view. And that's what text view actually uses. And if you want to scroll something more complex, like let's say an image view with a linear layout with some event view inside, you will probably use a ScrollView. So ScrollView is an implementation of a scrolling container that, well, uses most of the implementation that is inside View, but also contains some implementation inside its own class. So you can see that here that the framework is a little bit complex about this because the implementation is not only contained into a single container. And actually, the problem with ScrollView is that it only scrolls vertically. So if you want to scroll horizontally, then you have to use another view, which is horizontal ScrollView. That's, well, very easy to understand, horizontal and vertical scrolling. No, ScrollView, not vertical ScrollView. And if you want to have a lot of items, you will probably use another container like an abstract ListView, so which is an abstract container, so you will use a concrete one like ListView, or the new RecyclerView. So it's not used anymore, but it's relatively new compared to the Android history. And if you want something like page scrolling, you will use another container, a view pager. And if you want a map, another container, once again, a map view. And as you can see, there is some dashes at the bottom of the slide, because there is some other containers that are available in the framework or the support library, like the sliding drawer, which is now deprecated, the DrawLayout, the sliding pane layout. All of that stuff is actually scrollable. So you can see that there is a lot of scrolling containers. Another one is Webview. Webview is a scrolling container. You can scroll vertically, and if you zoom in, most of the time you will be able to scroll vertically and horizontally at the same time. Yeah, there is no horizontal Webview. And if you look at this compared to iOS, well, iOS is way easier because there is UI view, which is the equivalent of view, but it doesn't support scrolling by default. What you have to use is UI ScrollView, which is the equivalent of a ScrollView on Android. And all of the scrolling logic and you know, the kind of behavior that we will see in the rest of this talk is actually contained inside UI ScrollView. So everything is here, and when you are a beginner on iOS, you don't have to think about which container you have to use. Just use ScrollView or one of the descendants of ScrollView. And there is three actually direct descendants that are offered to you by the SDK: the UI collection view, which is the equivalent of RecyclerView; the UI table view, which is ListView; and UI text view is an equivalent of, let's say, text view. So now that we know how we can, you know, put scrolling content inside your application, you will probably want to listen to scrolling events. So basically, to know when the user is scrolling. So what we do as Android developers most of the time is to go to the d.android.com and look for a listener on scroll something listener. And if you look at on-scroll something listener, you will see that there is a bunch of on-scroll something listener. There is on-scroll change listener, on-scroll listener, on-scroll changed listener, and sometimes there is also the exact same name of the interface in several classes. So it's a little bit, it's a mess, let's be honest. But most of the time you will use actually only this kind of tricky trick. You will actually need to listen to scroll events just by overriding the on-scroll change method. So let's say I have a scroll view and I want to listen to scrolling events. What I will do is override the on-scroll change method. And what you have as parameters is 4 values, so basically two pairs of values. The first one is the old scroll values, so the X on the vertical and the horizontal axis. You have also the old and the new values. So this is pretty useful when you want to know where you are inside this window of content. The thing is, this is not great because, as you remember, composition over inheritance, whenever you want to listen to scroll events, you have to override a view and override a method and extend a view. That's quite a pain in the ass, but this is not the case anymore thanks to Marshmallow, so we will use it in 5 years. But you just have to set an on-scroll change listener now. So it's actually working on API 22 because it was hidden in 22 and it was unhidden in 23. So if you're using it, but don't do that, you can actually make it work on 22. But what you can do now is just set an on-scroll change listener and no more override. And you have the exact same kind of value with the old and the new values, scrolling values. So this is how to do that, at the view level. So if you have several scrolling containers, you will have to set a listener to all of those scrolling containers. But you can do that actually globally at the window level, or let's say the view hierarchy level, using something that is called a view tree observer. So I'm pretty sure that you're used to that, and you can actually add an on-scroll change listener, so changed this time with the D. And you have a method which is on-scroll changed, but there is no parameter. So you don't know which view has been scrolled, you don't know how much it has scrolled, and well, because of this, you have to just know about this. You just know about something has scrolled in the UI, but I don't know what. And actually, we will see that it's not that easy. So let's start a small quiz. Let's have fun, it's quiz time. So this is the code that I want you to, to focus on. It's very simple. It consists on having a view. You set a listener on it, so it's just working on API 23, I know. And this listener does something very simple. It logs the current scroll X and scroll Y values. So let's start the quiz time. What about if a view is instance of ScrollView? What do you expect? I mean, in the log cat. Well, you will have something like this. You will have scroll. The scroll X doesn't change because ScrollView is a vertical container, but the Y value will change. So as you can see here, the Y values are increasing because I am scrolling to the bottom of the container. So this is quite, well, natural. What about if a view is an instance of Webview? Do you think it will work? Do you think we will have something in the log cat or nothing? Well, actually, it works. Yep. And here you can see that the Webview is only scrolled vertically. But actually, if you're zooming in, then the values will change because the scroll X can change too. And obviously, because one unit of value here represents 1 pixel, if you zoom in, then the values will increase too. What about if a view is an instance of ListView? This is the kind of result that you have. So remember the name of the method, onScroll changed, but we have the same value. So we have scroll 0, 0, whatever something has changed. Well, when you're scrolling, the ListView scrolling position is changing, but you still have 0. You just have the callback that something is scrolling, but you don't know about where you are in the ListView. But sometimes you have some negative values. And this is the case actually when you have overscrolling, so basically going beyond the bounds of your contents. This is the case when you're flinging quite rapidly to a bound of the ListView. So why those 0 values? Well, that's because of the implementation of ScrollView versus ListView. So ScrollView knows it's predictive scrolling, basically, so you know about the actual height of the content, but in ListView, you don't know about this. So instead of giving you some wrong values and, well, useful values, ListView just notifies you about the fact that something has scrolled, but it doesn't know about the actual position in the content because it doesn't know about the content height. So that's, well, a good part. Even if it's not perfect, it's better than nothing. The ideal part would be to actually give you the delta, the scrolling delta inside, instead of the scrolling position. And that's actually the case also for RecyclerView. RecyclerView uses the exact same mechanism. It doesn't know about the content height perfectly. Instead of giving you some weird values, it gives you 0 like this. What about if a view is a DrawLayout? So you remember what it is, DrawLayout. Well, this time you will have nothing because it scrolls, but you don't have a scroll event. And what about a map view? Nothing. It's a scrolling container. So all of this to tell you that scrolling on Android is a mess. It is, really. But actually, I think it's because of most of the time legacy reasons, but it's really complicated. It's not only complicated on Android, it's complicated in general. So as you can see, I've tried to troll about iOS versus Android. This is not actually the point here. I think the point is that it's not a fight between iOS and Android. It's a fight actually between consistency and customization. So on iOS, when you want to have something scrolling, you will use a ScrollView or something that extends ScrollView. And just by doing that, you will have the exact same kind of movement animation, the same friction, the same type of scrolling, all of that stuff. When you want to do that on Android, you have to do that on your own. And it means that you have more control over what you can do, but also you have to stick to the, the general look and feel and kind of behaviors of the other views in the framework. So it's really a fight between consistency and customization. So what about if you want to create your own scrolling container on Android? Then there is, let's say, 5 behaviors that you have to to stick to. The first one is initialization. The second one, optional, of course, is movement tracking. As I said, you can scroll without having to track the movement of the fingers. Then inertial scrolling, or the fling part. The scroll bar drawing, which is pretty handy for people to know where the content, the displayed content is inside the overall content area. And finally, edges feedback, which is bouncing on iOS and edge effect on Android, you know, the glow that you have when you're reaching a bound in a scrolling container. So let's start with initialization. First, you have to tell the system that the view that you're creating is a scrolling container. So you can do that just by calling setScrollContainer and passing through. This is useful actually only mainly for one thing. It's when you have software input methods. So basically when you have a Windows soft input method set to adjust unspecified in your Android manifest, then the system will actually look for a scrolling container in the hierarchy. And if there is one, instead of moving to the top the content, it will resize the content because it makes the assumption that the content can scroll actually inside the scrolling container. So just by calling that, you will let the system compute if it can pan or resize the content. The other method that you should override, but actually the default value is true for legacy reason, is the should delay child press state. So as I said, it has been introduced in API 3, if I remember correctly, and the default value is true for legacy reasons because this is what the behavior was before. But basically what it consists on is to, let's say that you have a scrolling container and you want to put a view inside. When you tap, for instance, on this item in the ListView, you don't want the view to highlight to the press state. You want probably to scroll, and you don't want to see the view to highlight to the press state and then turn back to the normal state. So thanks to that, you can prevent this just by asking the system to use a small delay of time to compute whether the gesture is actually a tap or a scroll. And then, most of the time in the initialization part, you will try to get some values that are useful to compute the velocity or to make sure that the gesture is a tap or a scroll. So basically, you will find all those dimensions inside a very useful class called view configuration. And here you can get the get minimum fling velocity. So basically, if the finger velocity is beyond the minimum velocity, then there will be a fling. If it's below, you won't animate the fling scrolling. And if it's beyond the maximum scroll velocity, what you will do most of the time is to bound that to the maximum because, well, some values may be weird or too rapid to be actually natural or correct. And another very interesting one is the get scaled touch slope. So when you want to scroll, you touch the finger on screen and you don't move your finger. Most of the time you think that you don't move your finger, but actually the precision of the touchscreen are so, touchscreen are so precise that actually your finger is moving. And considering that a moving finger is a scroll is wrong actually. So what you will expect most of the time is to move the finger beyond a given dimension, and this given dimension is the touch slope. That was the initialization part. And then there is the movement tracking. So as I said, it's optional. You can do scrolling without this, especially if you're doing, I don't know, like trackball or programmatic scrolling. So I don't want to deep dive into the movement tracking because it's really tied to the touch input mechanism on Android. But basically what it does is it gives you an event, a motion event, which may have several types of actions. So here I don't handle multi-finger or multi-touch actions, but what you will have most of the time is an action down, which means that you're starting a gesture. So this is where you will stop all animations and you start a new gesture. So why do you stop animations? So for instance, let's say you're flinging a view. When you touch the view, you're flinging, sorry, a list view. When you touch the list view, everything stops because you're touching the object and you don't want to move You don't want it to move anymore. Then there is action move, which gets called whenever you're dragging your finger on screen, and this is where you will actually move and drag the object below the finger. Then there is action up. This is the end of the gesture, and this is where you will compute the velocity of the finger and potentially start animating the object regarding the velocity of the finger. And finally, action cancel, which is a virtual motion event that occurs when the parent has intercepted a gesture. So let's talk about inertial scrolling, or the fling. So whenever you want to do inertial scrolling, there is two parts. The first one is to track the velocity of the finger, and the second part is to animate the object according to this velocity. And tracking the velocity can be done using one very handy class in the framework, which is velocity tracker. So whenever you want to track the velocity of a finger, you will use this class, which is very simple to use. You just call the static factory method obtain, and you get a velocity tracker. And whenever there is a new motion event, you add this motion event to the velocity tracker. And when the gesture is done, so basically action up, you can ask the velocity tracker to compute the current velocity with a magic number of 1,000, which means that you will have some values in meters per second. You can use 1, 2, but I don't remember the output. So just read the documentation to understand this value. And if the velocity, the current, let's say here, the x velocity, so the velocity on the x-axis is greater than the minimum velocity, then you can start a fling. So what you will do actually most of the time is to use the absolute value, because here the code is not perfect. So if you're scrolling in that direction and in the other direction, you want to make sure that the direction doesn't influence the behavior. You want the fling to occur anyway. And if it's not, once the gesture is done, you have to recycle this velocity tracker, because this velocity tracker can be reused between views. So make sure that you call recycle and you set the reference to null. So as you can see, there is no break actually after the action up. So I know this is not clean code, but there is some nice conference about clean code this afternoon. So basically what you have to do is to make sure that this code is called in both cases. And once you know about the velocity of the finger, you can animate everything. Your object, to be more specific. And what you will use is an Overscroller. So there is two classes in the framework. The first one is Scroller. Let's say this one is deprecated. And the Overscroller, which is the new Scroller class, it does the exact same kind of stuff instead of just overscrolling. So basically, a scroller will be an object that you can use to animate an object. Overscroller will be a class that you can use to animate an object from regarding a velocity or just between 2 points. So here what we do is just to call the fling method on the Overscroller, and this fling method takes a lot of arguments, but actually it's quite simple. Basically it requires 4 pairs of values. The first pair is the current position, the second pair is the current velocity, the velocity at which you're throwing the object, and the 2 final pairs are the bounds of your scrolling containers, so the minimum and maximum x and y values. And then you will post a runnable inside the event loop, so that you are actually, gets called every frame to compute where the object is. So here what we do is post an animation, and you pass an mscroll runnable. And this runnable, in this runnable, what we do is we compute the scroll offset, and this method returns a boolean. If it's true, then the animation keeps going on, so you have to get the current x and y values and move the object accordingly. And finally, post yourself once again for the next loop. If the value is returned by compute scroll offset is false, then the animation is done and you have nothing else to do. What about scroll bars drawing? So as I said, Vue has some scrolling implementation, and it's actually at the view level that scroll bars are handled. So you can style them, you can move them around, so you can draw them on the left rather than on the right. You can do whatever you want. And all of this is done via setters on View. But View doesn't know about your scrolling content. So you have to inform View about the height and width of your scrolling, your window of content. And obviously, this can be done using overriding 3 methods. The first one is compute vertical scroll extend, which basically gives you the size of the scroll bar. The compute vertical scroll offset gives you the position at which you are in the content. And finally, the compute vertical scroll range gives you the actual height of your content. So here you have only the vertical version of the method, but there is also some horizontal counterparts. So all of this only informs View about the actual size of your content, but it doesn't ask View to draw the scroll bar. And you can do that actually just by using awaken scroll bars, which is a method that once again returns a Boolean. And if this Boolean it's true, then you have to invalidate to render the animation. And this method should be invoked whenever a scrolling position has changed inside your view. So whenever you're scrolling, make sure that you're calling this awaken scroll bars. And this is just to inform you to draw the scroll bars, but you have nothing else to do. I mean, you know the fact that, for instance, when you are entering a screen, the scroll bar flashes just to inform the user that you can scroll. This is done at the view level. So you just have to call this method. And finally, edge effects. So basically, this is the type of glow that you have when you are reaching a bound. So here in the setting application, when I'm trying to pull down the content, I can see that there is a glow that appears. And if I release my finger, this glow will, reduce and fade away. And this is done using edge effect, the edge effect class, which is API 14. But there is a compact version in the support library, but normally you should be min SDK 14 at least. So don't use edge effect compat, or it shouldn't be useful for you. And the edge effect can be done in 2 parts too. The first one is to draw it. So what you can do is to override the draw method, and what you will do is to call the isFinish method. Once again, this method returns a Boolean, and regarding this Boolean, you know if you have to draw or something or not. If the top edge effect is not finished, then you have to draw something. You can move the canvas around to draw the edge effect at the correct position. You set the size of this edge effect. Just most of the time, what you will use is to get the width of your content minus the padding, and you will set this to the edge effect. And finally, you can draw this edge effect. And here again, you can see that this method returns a Boolean. And if this Boolean is true, then you have to repost yourself on the next loop. And this is what I do here by using post invalidate on animation. So this is just the drawing part, but you also have to set the state, basically, to inform edge effect that the user is flinging or reaching a bound or pulling down the content. And this can be done using 3 methods. The first one is onAbsorb, which requires a velocity. So it's basically when you're reaching a bound, you just pass the current velocity to the edge effect, and regarding this velocity, a glow will draw automatically. Then there is onPull, so this is when you're trying to pull down the content from an edge. And finally, there is onRelease. OnRelease is called when you have to call it when, the user is not touching the screen anymore. So this is, I think the big picture about how to create your own scrolling containers. But sometimes you only want to stick to the containers inside the framework. And that's okay with that. But the thing is, there is some problem when you try to nest them. So when you want to put, let's say, a ScrollView inside a ListView, or, this one is pretty tricky, but if you put a horizontal ScrollView inside a ListView, this one is normally okay. So what's the simple and elementary solution? don't do it. This is the easiest way is not to do it. But I know that it's not great because some of the time you want some interaction, patterns that consist on putting a scrolling container inside another scrolling container. But basically, it's okay as long as you stick to this rule. So one axis, one scroll. If you stick to that, it's okay. So as I said, putting a scroll view, so a vertical scrolling inside a ListView, which is also vertical scrolling, you're doing something wrong. But if you try to put an horizontal scroll view inside a ListView, it will be okay, because horizontal scroll view will catch all gestures that are done horizontally, and ListView will actually only take care of the vertical axis. So it's okay. But sometimes you want to go beyond that because, well, you want to have two kind of scrolling on one axis. And there is several solutions for that. The first one is what is called Bezel scrolling. So here we have an animation. So as you can see, we have, we can scroll horizontally and vertically, but we want also to be able to display a draw layout, a drawer, on the left of the screen. And what we can do here is just to use Bezel scrolling. So instead of scrolling, so when you're inside the content, so in the middle of the content, you scroll. But if you start typing on the edge of the screen, instead of scrolling, what you will do is to open the scrolling container here, a draw layout. So this is done actually just by using onInterceptTouch event in the view class. But if you want to do it, actually, just by using those classes like DrawLayout or ViewPager, then you will have Bezel scrolling by default. And most of the time, this tiny area is like 20 dp's wide, width of 20 dp. So it means that if you're trying to scroll, let's say some instance you want to scroll the content, sometimes you may open the drawer instead. So this is what I don't like personally regarding this type of scrolling, is that you may have some wrong positive or false positive, I don't know how to say that, but sometimes you want to scroll instead of opening the drawer or the other way around. Another solution is Banderas scrolling. So here, once again, we have a view pager in Gmail, and we have some pages, sorry. So when we zoom in a page, we can scroll inside that page, but we may want also to change the page. So what we do here is we touch the screen, then we drag until we reach the bound of this scrolling container, so basically the Webview, it's a Webview. And once this Webview cannot scroll anymore, then the view pager will actually consider the gesture as a paging gesture. So this is quite nice, especially for Gmail. I think the interaction model is perfect, but it has one disadvantage, I would say, is that you have to release your finger here because you are at the bound, and then start a new gesture. So basically you have to swipe twice to change the page. So this is the problem with Banderas scrolling. And ViewPager actually uses this kind of scrolling. And in order to do that, it uses two methods. The first one is can scroll vertically, which takes an int, and the second one is can scroll horizontally, which also takes an int. And this int is actually just -1 or 1, depending on the direction. So if it's positive, you want to scroll to the right or to the bottom, and if it's negative, you want to scroll to the left or to the up. And so basically, when you want to put some scrolling containers inside of ViewPager, you may want to override those methods and return the correct Boolean regarding the direction of the scrolling. So this is what we used to have, but starting Lollipop, we have something called nested scrolling, and this nested scrolling lets you create nice animation like this one. So here you can see that we have a RecyclerView with a shrinking toolbar, let's say, and what we will do is only one gesture to scroll. So the first part of the gesture only shrinks the toolbar, and then it starts scrolling the RecyclerView. And I don't have to scroll twice, just like I used to do with Banderas scrolling. And this is done thanks to nested scrolling. So nested scrolling is, let's say, well, it's quite difficult. There is a lot of methods that have been added in Vue. So I won't deep dive into detail, but you have to know about this. And what it consists is basically to really just focus on scrolling. So Banderas scrolling lets the view handle the touch mechanism. So basically, when you're touching a view, it handles its own scrolling. But in the case of nested scrolling, here RecyclerView will actually take care of the scrolling, so the touch, sorry, but can delegate the scrolling to another view. And this another view is actually a parent here that contains the shrinking toolbar. So how can you use that? Well, you can use it starting API 21, obviously, especially ScrollView and ListView are implementing this nested scrolling, but it only works on API 21. If you want to use that on your, let's say, min API 14 API, you will probably have to stick to nested ScrollView, which is part of the support library, or the RecyclerView, which is also part of the support library. And a funny point here is that if you use horizontal ScrollView, then you won't have nested scrolling because they forgot, or I don't know. It's not implemented inside horizontal ScrollView, and there is no nested horizontal ScrollView in the support library. So that's another good point here, that if you want to have some nice scrolling animations, you probably want to stick to RecyclerView instead of ListView, because there is no ListView compat or backport inside the support library. So to create the kind of animation that I had on the previous slide, you will probably want to stick to RecyclerView. And I think we're done regarding the time. So thank you very much, and if you have any question, feel free to ask. No questions? Wow, nice. Okay, thank you.